Hello, welcome to my channel, my online tutorials. Today I'll be taking you through the topic Lewis structure. This is a topic I had difficulty with when I was in the senior secondary school until I went to the university. Because of the difficulty I had with it, I decided to take you through it. In this lesson, we will be looking at 1. What a Lewis structure is. 2. Some essential features of Lewis structure. 3. The skeletal structure and the strategy involved in writing Lewis structure. And finally, we will write the structure of cyanogen, C2N2, nitronium ion, NO2 plus, water, ammonia, boron fluoride, carbon dioxide, and sulfur dioxide. So, grab a paper and let's start this lesson. A Lewis structure is the representation of the valence electrons in a molecule. Valence electrons are those electrons that occupy the outermost shell of an atom. For example, carbon has atomic number of 6. You can look it up on the periodic table over here. Valence. Its electron configuration is 1s2, 2s2, 2p2. Hence, carbon has 4 valence electrons. A Lewis structure shows how the valence electrons are arranged around individual atoms in a molecule. Now, let's look at some essential features of Lewis structure. These features will guide your understanding of the structures. Below are the features. First, all the valence electrons of the atoms in the Lewis structure must appear in the structure. The next feature is that usually all the atoms in the Lewis structure are paired. The third feature is that usually each atom acquires an outer shell octet of electron. What this means is that when the structure of a molecule is written, each atom in the molecule must be surrounded by 8 electrons. But hydrogen, however, is limited to 2 outer shell of electrons. The last feature says that sometimes multiple covalent bonds, which could be either double bond or triple bond, are required. Elements like carbon, nitrogen, oxygen, phosphorus, and sulfur are known to form multiple bonds readily. Let's go on and look at the skeletal structure because it serves as a stepping stone in writing a Lewis structure. To be able to write the Lewis structure of a molecule effectively, you must be able to designate the skeletal structure of the molecule. The skeletal structure shows all the atoms and how they are bonded to one another. For skeletal structure with more than 2 atoms, we generally need to distinguish between central atoms and terminal atoms. Central atoms are those atoms bonded to two or more atoms, and terminal atoms are bonded to just one other atom. Let's look at some additional facts about central atoms, terminal atoms, and the skeletal structure. Hydrogen atoms are always terminal atoms, since hydrogen can accommodate a maximum of 2 electrons. Because of this, it can bond to only one atom. Central atoms are generally those atoms with the lowest electronegativity. Electronegativity determines the ability of an atom to pull towards itself electrons when it is in a covalent bond with another atom. Electronegativity generally increases across the periodic table. An atom with the lowest electronegativity compared to another atom loses its electrons partially to the other atom. Carbon is always a central atom. So let's proceed and look at the most important part of this lesson. Strategy for writing Lewis structure. This strategy has been listed chronologically, that is step by step. So first, you need to determine the total number of valence electrons in the compound that must appear in the structure. Next is to identify the atoms that are central atoms and those that will be terminal atoms. Next, you write a plausible skeletal structure for the compound. Next, you count the total number of bonds in the skeletal structure. Multiply the number of bonds by 2 and subtract it from the total number of valence electrons that you have calculated. Now, the bonds are represented by dashed lines between the atoms. With the remaining electrons, first complete the octet of the terminal atom. Continue and complete the octet of the central atom to the much possible extent. This means that till there is no more valence electron left. After you finish completing the octet of the terminal atom and sometimes also the central atom, count the total number of bonds and valence electrons around individual atoms. If they are not up to 8, then move to the next step. Already, we know that hydrogen can take a maximum of 2 electrons. So, you are expecting only 2 electrons for hydrogen. That means for hydrogen, it will not be 8 electrons around the hydrogen atom, but 2 electrons. In the final step, if one or more central atoms are left with incomplete octets, move lone pair electrons from one or more central atoms to form multiple covalent bonds. Now, let us write the structure of some compounds. So I'll be guiding you to write the structure of some compounds, and later I'll do another video to explain the others. I think I'll be taking cyanogen and nitronium ion for this presentation. The strategy we have outlined earlier will guide us to write the Lewis structure of cyanogen, which has a molecular formula C2N2. The first step in writing the Lewis structure of any compound is to determine the total number of valence electrons in the compound. So what we will be doing first is to determine the total number of valence electrons in C2N2. Carbon has 4 valence electrons in its outermost shell. And from the molecular formula, there are 2 carbons. So we multiply the 2 by the number of valence electrons in carbon. Nitrogen, when we look at the periodic table, it has a total of 7 electrons but 5 valence electrons. So we add it to the valence electrons of the carbon. There are 2 nitrogens in the molecular formula. So we multiply the 5 by 2. And this is equal to 18 electrons. The next step is to determine the central atom in the compound. When we're looking at central atom and terminal atom, we said that carbon atom is always a central atom. What that means is that when we are given any compound and there is carbon atom in it, that carbon atom will be the central atom in that compound. So because of that, carbon will be the central atom and nitrogen will be the terminal atom. The next step is to write the plausible skeletal structure. We said that the plausible skeletal structure will serve as a stepping stone in writing the Lewis structure because it will give us a broad idea about how the structure will be like. So we write the carbon being the central atom, and this dash over here represent the bond between the carbon atom. This dash has 2 electrons in it. So whenever you see a dash, you should know that there are 2 electrons. And we have the terminal atoms around it, which are the nitrogen atoms. What we'll be doing next is to count the total number of bonds in this skeletal structure. So we said that a dash over here has 2 electrons. So we count the total number of bonds. 1, 2, 3, 4, 5, 6. Or simply we can count just the dash, which is 1, 2, 3, and multiply it by 2. And that will give us 6 electrons. Next is to deduct the 6 electrons from the 18 electrons. And that will give us the number of electrons that we will use to fill the octet of the terminal atoms. And when we deduct the 6 electrons from the 18 electrons, we have 12 electrons. So we'll fill the octet of the terminal atom first. So now we are filling the octet of the terminal atom. Filling the octet of the terminal atom. So we have used these 12 electrons over here to fill the octet of the terminal atoms, and we have used all the 12 electrons, so we cannot continue with carbon. That means we cannot fill the octet of the carbon atoms. So the next thing we will do is to count the lone pair of electrons over here and the bonded pairs. We call this one the bonded pairs, and these electrons over here, the lone pair of electrons. So we'll count them and check if we have enough. So when we count the bonded pairs and the lone pairs around the nitrogen atom, we can see that they are 8. They are 8 in number. That means the bonded pairs and the lone pairs are 8. And the same goes for this nitrogen on the other side. But when we count it for the carbon, let's try it. 1, 2, 3, 4. And for this carbon too, we have 1, 2, 3, 4. That means the carbon atom, which are the central atoms, do not have a complete octet. So we go on to the final step, which is to use the lone pair of electrons and form multiple bond. We'll use these 2 electrons over here, or any of the lone pair of electrons, and form a multiple bond between the nitrogen and the carbon atom. And we'll do it for this side too. So that's what we've done over here. So we can see that the lone pair of electrons around the nitrogen atoms in the structure is now 4 instead of the 6 that we saw over here, because we have used 2 to form a multiple covalent bond between the carbon and the nitrogen. So we cross check and see if our carbon atoms now have a complete octet. Let's see. 1, 2, 3, 4, 5, 6. And we know that for this carbon 2 is also going to be 6. And from that we can see that the carbon atoms do not have a complete octet. So we will go on and use 2 electrons from the nitrogen, 2 lone pair electrons from the nitrogen atoms to form another bond between the carbon atom and the nitrogen atom. So once again, the lone pair electrons around the nitrogen atom have now reduced to 2 on each side, and we can see that our carbon atoms now have a complete octet because we have 3 dash joining the nitrogen atom and the carbon atom, and 1 dash joining the carbon atoms. So this is the Lewis structure of cyanogen. This is the Lewis structure of cyanogen. Our next example is to write the Lewis structure of nitronium ion. We'll be using the same strategy that we used when we were writing the Lewis structure of cyanogen previously. The first step is to determine the total number of valence electrons in nitronium ion. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons, and we have 2 oxygen atoms in nitronium ion. The positive sign over here indicates that there has been a loss of electrons in the nitronium ion. So we'll bring all that information to find the total number of valence electrons in nitronium ion. So we have our 5 for the valence electrons of nitrogen. We add the 6 and multiply it by 2, and we subtract 1, which is the positive sign over here, and we'll have 16 valence electrons. The next step in writing any Lewis structure of any compound is to determine the central atoms and the terminal atom. We said that for central atom, they have the least electronegativity, and on the periodic table, nitrogen has the least electronegativity because electronegativity generally increases from left to right on the periodic table. Oxygen and nitrogen are in the same period, but nitrogen comes before oxygen, which means that nitrogen is the least electronegative atom. What that means to us is that nitrogen will be our central atom and the oxygens will be our terminal atoms. So the next strategy asked us to write the plausible skeletal structure, and we said that is what will serve as a stepping stone in writing the Lewis structure. We build the Lewis structure on the skeletal structure. So we have our nitrogen atom surrounded by the oxygen atoms. Next is to determine the total number of bonds in our skeletal structure. The dashes over here represent the bonds, and each dash has 2 electrons in it. So we have 1, 2, that means we have 2 dashes, and we will multiply it by 2 to get the number of bonded electrons in this skeletal structure. So we have 4 bonded electrons in this skeletal structure, and we'll subtract it from the 16 over here. And when we subtract it, the answer that we get is what we will use to form the octet or fill the octet of the terminal atom. And if we can, we go on and fill the octet of the central atom. So when we subtract it, we have 12 electrons. So we use 12 electrons to fill the octet of the terminal atom. So now we fill the octet. we fill the octet, and now that we have filled the octet of the terminal atom, or we have filled the octet of the Lewis structure, we have to check if each atom has 8 electrons around it. From our observation, we can see that oxygen has 8 electrons around it. All the oxygen atoms over here has 8 electrons around it, but the nitrogen atom has only 4 bonded electrons and no valence electrons. In order to make the nitrogen also to have 8 electrons around it, then we have to form multiple bond. So we start with double bond. In forming the multiple bond, we move lone pair electrons from the terminal atoms and form a bond between the nitrogen and the oxygen atom. We do it for both sides. So we have our structure. So here we go. We have formed a multiple bond between the nitrogen atom and the oxygen atoms. Before we are fully done with writing the Lewis structure of this nitronium ion, we have to bring the positive charge which is on the nitronium ion. So here we have it, the Lewis structure of nitronium ion. I hope this video was useful to you. Kindly subscribe to my channel and hit that notification bell and be notified when I upload new content. Thank you very much for taking this lesson with me. Till we meet again, it's bye bye.